Alrighty, so now we've got a function to pre-process our images, aka turn them into tensors. We can now start to figure out what we need to do next. So we've got get data ready, turn it into tensors. Pick a model. Well, we're not quite up to this. So if we come back, if we were to read a little bit more into loading images in TensorFlow, we'd figure out that TensorFlow likes to see things in the form of a data batch, aka a tensor containing an image example or a piece of data example. Remember, this is data agnostic. We're just using images as our practical example. So it likes it in the form of, okay, give me a piece of data and its label as a combined tensor so I can process them really fast. And if you're wondering what a batch is, well, it's also called a mini batch, which is aka a small portion of your data. Now, generally, if you're wondering what a good batch size is or how much is a small portion, 32 is generally the default batch size with most deep learning models. And I'll show you, this is how I figure out a lot of things. So we go Yann LeCun batch size. And you might be wondering, who the hell is Yann LeCun? What is batch size? All these things are new to me. Well, I want to show you a little trick. When you find or when you hear of someone who is, let's say, a figure in the field of machine learning or deep learning, a trick that I use to figure out what they think of a certain topic is I Google their name and I Google the concept I'm looking for. Another one is Jeremy Howard. So Yann LeCun and Jeremy Howard, you could go Jeremy Howard batch size, Google that. I'm just telling you these two people off the top of my head. Yann LeCun, I'll let you research him, but he is one of the founders of convolutional neural networks, which is kind of what we're going to use to process our images. But getting sidetracked here. If we Google Yann LeCun batch size, and then we come to Twitter. Twitter is actually an amazing resource to figure things out. Look at this. Training with large mini batches is bad for your health. More importantly, it's bad for your test error. Friends don't let friends use mini batches larger than 32. Then we've got a paper here linked on different batch sizes. So I'll let you look into that. I'll link this tweet in the resources section so you can check out that paper. But this is what we're going to work towards. We're going to transform our data into batches of size 32 so they process really efficiently in TensorFlow. So let's make a little heading. Turning our data into batches. And these little tidbits, the one I just showed you, like searching someone's name, these kind of things I think are important, right? How would you know that if I didn't sort of tell you or you sort of didn't stumble across it? The only way I found that was by stumbling across, hey, there's all this great information that people are sharing. How do I find that every so often? And again, my way is not perfect, but it's helpful. I Google someone's name and a certain concept I want to find out about more. This is why it's important to share your work if you find something valuable. Okay, getting sidetracked once again, but why would we turn out something into batches? Well, let's say, why turn our data into batches? And if you're still confused on batches, we're just taking a small portion, 32 images, and calculating on those 32 images at one time. And then the next loop, the next training session, we calculate on the next 32. Because if we tried to calculate patterns in all 10,000 images, so here, let's say you're trying to process 10,000 plus images in one go, they all might not fit into memory. So what I mean by that is that a GPU has, although it's really fast at computing, it still has a limited amount of memory. And so my computer has 16 gigabytes of RAM. The GPU backing this might have 8 gigabytes of RAM. So if we have 10,000 plus images and we're trying to process the patterns on that in one go, that may be more than 8 gigabytes, which is going to slow down our training process. It's going to break everything. So that's why we do 32 at a time. So that's why we do about 32 images at a time. You can 32 images, batch size. That's right here. This is the batch size. You can manually adjust the batch size if need be. All right. So we spent enough time talking. Let's start writing some code. What do we need? So write it here. In order to use TensorFlow effectively, we need our data in the form of tensor tuples, which look like this. So image in the form of a tensor and label. So as pairs. So then we'd pass 32 of these at a time to our machine learning model, and it would figure out the patterns in this image that relate to this label. And then it would end up doing that in a sort of loop fashion until it gets through all 10,000 plus images. Whew. All right. Let's build some functionality. But first we need a way to get tuples. So we need, before we can turn them into batches of 32, we need to get a tuple that looks like this. So let's write a little function. So create a simple function to return a tuple of tensors. That rolls off the tongue nicely. So we want to go def get image label, because we've got a function here that's going to return our image. So all we want to do is just basically get the label associated to whatever path we pass this function. So we'll go here, image path, and now really you're going to laugh at me for how simple this function is, because all we're doing is passing it the image path, the actual label, and the image pre-processing function we just wrote. So process image path, and then we want to go return image label. Look at that. How basic is that? So takes an image file path name and the associated label, processes the image and returns a tuple of image label. The docstring is longer than the function. Beautiful. We didn't even need that line. We could have just done it all return here. Now let's just give a quick example there. Let's just see exactly what this would look like. Process image. We want file names. Let's get 42, our favorite number. And what is it? What's it called? Boolean labels. We could just use X and Y, couldn't we? That's probably a bit better. X, Y, 42. Demo of the above. Beautiful. So that's in a tuple. Our image is in a tensor because we pass it to process image, but our label is not yet in a tensor, but that's all right. We could turn it into a tensor by just going tf constant. There we go. So now we've got a tuple of an image and label pair in the form of tensors. Now we're making some good progress here in getting our data ready. Remember how I said a lot of machine learning is just pre-processing your data into a format that fits into a machine learning model? That's what we're doing here. And now, again, this process we're sort of taking, getting our data into the format of data label in a tuple of tensors, is agnostic to whatever data you're using. So if you're not using images, you're using something like text, this would be a very similar process, except the way you pre-process the text will be different to the image. You still have to get it into tensors. All right, so we've got a little function to get image and label pairs in the form of tuples. We'll write a function in the next video to turn our image and label pairs into batches. And there's a few little tidbits that we need to pay attention to depending on if our images are in a training batch, a validation batch, and a test batch. But we'll see that in the next video.